This is 8.3. What we're doing is we're actually taking 8.2 of graphing the sine and cosine functions, and we're taking it to the next step. The only thing that's going to be different in this section is we're actually going to be shifting things. So in previous courses or Algebra 2 or some of the things that we've done is we've learned how to shift things horizontally and shift things vertically. So what we want to make sure that we understand is that the equations are given to us. They're exactly the same as they were before. The only thing we're adding in there is we have a k, and k is now on this side, which we can move to the other side, it doesn't matter, but the k will represent our vertical shift. The h is going to represent our horizontal shift. And notice the minus signs are there. So if the shift is going up 3, then it's going to still be minus 3. It will be opposite, obviously, if it's going down or going to the left. So what we're going to do is we're just going to go over 2 examples in this section. One is going to be if we're given a function and what the equation is. So let's talk about this. So the first thing that you want to do when you're graphing this, when you're coming up with an equation, is the first thing you want to look at is where is the middle of the function. So notice our graph here is actually shifted. So what I do is I always draw a dotted line going across where what we call the axis of the function is. So that's where it's going to be dividing it right in half. Okay? So that's the first thing that you want to do. Then what you want to do is you want to label everything that you know. So we start with amplitude. So the first thing is amplitude, and if you notice we have a formula up here that will help you figure out what the amplitude is. It's the y value that's on top minus the y value that's on the bottom, and then just divide that by 2. So the y value up here is 5 minus the y value down here, which is -1, divided by 2. So 5 minus -1 is 6. 6 divided by 2 is 3. So our amplitude here is going to be 3. Obviously, that's going to help us write our equation. The next thing that we want to look for is the period. Remember, when you're given a graph, you can figure out the period by simply figuring out how long it takes to go through one cycle. So I usually pick my maxes or mins, and I just figure it out. So we're starting at 3 here. That's 3. That's our x value. And we're ending at 11. So the difference between those two is 8. So the period of our function is 8. From that, because now that we have the period, we can figure out what the frequency is. And the frequency is important because that's part of our equation. That's the b. So we do frequency is 2 pi divided by the period. So we have 2 pi divided by 8. And if we reduce that, that will be pi over 4. So now we have our frequency. So now that we have these 3 things, we can start to construct an equation. Now, one thing that I want you to be careful about is you should be able to do this in terms of cosine and in terms of sine. This could be a cosine or a sine function. There is no right or wrong answer whether you come up with a sine or a cosine function, and a lot of the things that you'll have to be assessed on are going to ask you for both. So what I'm going to do is I'm going to start with a cosine function. So first what we want to do is we have this information. Now I want to think about what is our vertical shift. Well, if you look at our dotted line, that is our new axis. So if our old axis was down here at the x-axis, just figure out how much you shifted up. So we shifted up 2 here. So therefore our vertical shift is we went up 2. Now what we're going to do is, before we deal with a horizontal shift, let's decide which function we want to do first. Let's say we start with cosine. So if we're starting with cosine, what you want to imagine is the peak or the maximum always starts at our y-axis. So basically you can look at this and say, if the graph normally would have started here, what did we shift? We shifted to the right 3 units. So therefore, if we're going to do a cosine function, we will start it off like this. Y minus our vertical shift is 2 equals, and then we have our amplitude is 3. So that means we have 3 cosine. And we have our frequency is pi fourths. And then in parentheses, that's where our horizontal shift is going to come in. And for the cosine, it was a shift of 3 to the right, so it's just minus 3. So there's our function for a cosine. When we do the sine, we got to do this a little bit different. Now you've got to determine, the sine's a little bit harder because you have to determine where the sine would be. So again, always think about the axis. The dotted line is where our sine is going to start, because that's where the sine normally starts. So hopefully you can figure out from this graph that this is where the starting point would be of the normal sine function, because it's increasing. And this is where it was supposed to start. So therefore our shift here for our sine function is only 1. So now everything else is the exact same for our sine function. The only thing that's different is the horizontal shift. So instead of it being -3, it's just going to be -1. And that's the sine function. So both of those are the functions for this graph. Again, identify everything first. That gets you started. Start with either cosine or sine. Depending on what you start with, determine what that horizontal shift would be based on what you know our starting point should be. Cosine is always that top point. You know the sine is going to be the part that's increasing, and it's right in the middle. So you just got to determine that. That's the only real tricky part about that. Okay, now let's talk about actually graphing a function. So what happens when we're given an equation and we want to graph it? Well, believe it or not, we're going to go through and we're going to start identifying. So this is going to be the vertical shift. So first look at the vertical shift. Well, because it's -3, we know the vertical shift is 3. The horizontal shift is going to come from our x value in parentheses. So if you look at that, that's -1, so the horizontal shift is going to be a +1. We also know what the amplitude is because of what is in front of our cosine, so the amplitude is going to be 2. We also know what our frequency is. Remember, when we're given the equation, we know what the frequency is, but not the period yet. So the period, which is the very important part to figure out before we can graph, is always going to be 2 pi divided by the frequency. So 2 pi divided by pi halves, the pi's cancel out, and we have 2 divided by 1/2, so the period there is actually 4. So again, the reason why that's important is we know that it will take a full 4 units for us to complete one cycle of our function. So we're dealing with a cosine here. So here's what I want you to do. We have all the information that we need. But what I want to do is let's graph the parent function. Now this is going to make this a whole lot easier if you graph the parent function first. This is what the parent function will always be, in my opinion. The amplitude, the frequency, and then the x. Don't do any of the shifting, because then what we can do is we look at this and we say, okay, I know that a cosine function normally starts at 1, but because the amplitude is 2, I know that I can start it at 2. Because I'm starting it at 2 and the period is 4, I know that wherever I start, I go a period of 4, and I'm going to be in the exact same spot. So if I go another period of 4 the opposite way, I'm going to be in the exact same spot. Now here's the best thing about cosine and sine functions. They are perfectly symmetrical. So therefore, if I know that I'm going to be at +2 at these values, I know directly in the middle I'm going to be at -2. Perfectly symmetrical, which means that if those are, obviously some of you want to draw this as a V, but it's really not a V, it's a curve. But now we know where all the zeros are going to be. Those are going to be exactly in the middle. So our parent function is going to look something like this. And please, I know it's hard for me to do on the Mobi here, but make sure it's a curve. It should not be V's going all the way across. So there's my parent function. Now from there, and I'm going to do this in a different color, all we have to do is shift it. So the shift is going to be 3 up, 1 to the right. So I take all of my points. 1, 1, 2, 3, 1 to the right. 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 1, 2, 3. Sorry, you missed one. 1, 2, 3, 1 to the right, 1, 2, 3, 1 to the right, and then so on, and you can draw your curve. And then that's what our actual curve is. So the goal here is to not make this too complicated. Figure out all of your information and then go from there. Remember, the period is the key because we know where we're going to start. We can figure that out from the parent function and from what's in front. The key here is knowing what the full cycle of your function needs to be. Remember, wherever your point is that you start, when you go one full period away, it's going to be in the exact same spot. So hopefully that makes sense. I don't have anything for you to do on your own. That's all we got. I will see you in class.